Zeal Education Society, redefining excellence.
Hello students, I am Dr. Mahadev Munde, Zeal College of Engineering and Research, Pune. In a previous video lecture, we have learned the RLC series circuit, their impedance and the various cases, the voltage expression and resultant current expression. Now in this video lecture, we are going to learn the series resonance and complex power. What is series resonance? See, when XL equal to XC, that is the cancellation of reactance takes place, is known as series resonance. It is the cancellation of reactance at a certain frequency, certain supply frequency is known as series resonance. The frequency at which resonant frequency the frequency at which the cancellation of reactance takes place is known as resonant frequency. The frequency at which cancellation of reactance takes place is known as resonant frequency. That is, net reactance is 0. XL equal to XC, therefore X equal to 0. So XL is nothing but 2 pi Fr into L, where Fr is the resonant frequency, say here Fr, equal to, what is Xc? 1 upon omega c, that is 2 pi Fr into c. So this can be written as Fr square equal to 1 upon 4 pi square Lc, and therefore Fr equal to 1 upon 2 pi under root Lc. So this is the expression for resonant frequency. Now what happens due to this resonance? See, as phasor diagram, as XL equal to XC, VL equal to VC. But what is VL? VL equal to VC, that is I into XL equal to I into X. So this is a series circuit, and therefore we will consider current as a reference factor. Current, oh, this is VR, and see, this is VL, this is VC, and see both are equal in magnitude, and therefore they cancel. And what is the remainder? Remainder is, this is I, this is VR. So So this will get cancelled. So it is a unity power factor, that is angle between phi and I equal to 0. Therefore power factor equal to cos phi equal to 1. So at resonance power factor is unity, and as there is a cancellation of reactance, impedance become minimum. Becomes minimum. Therefore, Z equal to R plus or minus Jx, but x equal to 0, net reactance is 0. Therefore, Z equal to R minimum. Therefore, current becomes maximum. I equal to and max equal to phi upon Z equal to phi upon R. So current during the resonance will be phi upon R or phi upon Z. Some features or the characteristics. Here the net reactance is 0. X equal to 0, therefore XL equal to XC, and therefore VL equal to VC, but opposite in direction. Now therefore second, Z equal to R equal to minimum, therefore I is maximum. I equal to phi upon R equal to phi upon Z. Third, power factor becomes unity. This is about the resonance. So now let us start the complex power. What is complex power? Let phi equal to phi mod angle theta 1. I equal to I mod angle theta 2. Therefore, complex power S equal to P plus JQ equal to phi into I complex conjugate. Now, what is a complex conjugate? See, I is we have considered this one. Complex conjugate of I angle theta equal to I angle minus theta. If it is I angle minus theta, it will become I angle plus theta. If it is 3 plus J4, its complex conjugate will be 3 minus J4. If it is say 4 minus J3, its complex conjugate will be 4 plus J3. So this is the complex conjugate. So we have to write the expression. So S equal to phi is phi angle theta 1 into complex conjugate of I is nothing but I angle minus theta. So this will be phi mod I mod angle of theta 1 minus theta 2. Now this is in polar form. This is in polar form, and this can be written as trigonometric form. In trigonometric form, it will become S equal to phi mod I mod cos of theta 1 minus theta 2 plus j phi mod I mod sine of theta 1 minus theta 2. Theta 1 minus theta 2. Now, when you compare this P plus JQ, therefore P is the active power and Q is the reactive power. Therefore, active power P equal to phi I cos of theta 1 minus theta 2, and reactive power Q equal to phi I sine of theta 1 minus theta 2. Now its unit is either kilowatt or megawatt. Here VAR, kVAR or MVAR. This is the expression for complex power. Now, P will be positive. Active power will be positive when theta 1 minus theta 2 is less than 90 degree but greater than minus 90 degree. This is the condition. This is the condition to have the active power positive, and the reactive power reactive power Q equal to phi I sine theta 1 minus theta 2. Whether it is positive or negative, that depends on sine of theta 1 minus theta 2. Q is positive for inductive load, that is for lagging power factor. See, this is a reference. Say this is phi, this is I, angle theta 2, angle theta 1. So this will be theta 1, this will be theta 2. Now here the current is lagging, and this angle is theta 1 minus theta 2. Obvious theta 1 minus theta 2 is positive. Here theta 1 minus theta 2 is positive. Therefore sin theta 1 minus theta 2 is positive, and therefore reactive power Q is positive. Now say the reactive power Q is negative at leading power factor, that is capacity load. Say this is a reference phi angle theta 1, I angle theta 2. So this is theta 2, this is theta 1, and therefore this angle is, or current is leading. So theta 1 minus theta 2 is negative. Therefore sine theta 1 minus theta 2 is negative. Thus reactive power is negative. When shunt capacitor is connected across the load, it delivers the lagging VAR. It generates lagging VAR, whereas it absorbs, meaning it absorbs leading VAR. The shunt capacitor used for power factor improvement generates lagging VAR, means reactive power. Reactive power, that is generates lagging VAR and that supplies to the load, that is absorbs leading VAR. So in this way, here we have finished the series resonance and the complex power. The complex power has two components. Capital S equal to P plus JQ. P is the active power and Q is the reactive power. We know the unit of active power watt, bigger unit is kilowatt or a megawatt, and reactive power unit is VAR or kVAR or MVAR. Now while obtaining the complex power, S equal to P plus JQ equal to phi into I, you have to take the complex conjugate. And already we have studied what is complex conjugate. Then the active power will be positive when the angle between voltage and current, that is theta 1 minus theta 2, is less than 90 degree and greater than minus 90 degree. Else the active power is negative. Then the reactive power will be positive when there is an inductive load or for lagging power factor. During lagging power factor, the Angle Q1 minus Q2 is positive and therefore reactive power is positive. Then reactive power may be negative at leading power factor. We have shown it here. The sign of Q1, the theta 1 minus theta 2 is negative and therefore reactive power is negative for leading power factor load or capacity load. The shunt capacitor generally used for the power factor improvement that generate the lagging VAR, that is reactive power which supplies to the load, that is it absorbs the leading VAR. We'll stop here. Thank you.